Greetings, welcome to our 42nd episode of the FGI podcast series. My name is Tim Stark and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. On today's episode, we are going to focus on our August 30th, 2022 webinar titled Microplastics and Geosynthetics. I'd like to quickly reintroduce our distinguished speaker, Francesco Fontana. He has been active in the geotextile market for 37 years. He's a current board member of the Italian chapter of the International Geosynthetic Society. Francesco served as vice president of the European Association of Geosynthetic Manufacturers, EAGM, from 2014 to 2017, and was president of the Italian Association of Geosynthetics Industries from 2006 to 2018. In 2020, Francesco was elected for a second term to the World Council of IGS, where he chairs the Corporate Members Committee. He's an active task force member of the IGS EAGM that responds to inquiries of the European Union regarding microplastics emissions from geosynthetics. And of course, that dovetails nicely with the title of the webinar, Microplastics and Geosynthetics. So, Francesco, thanks so much for joining us again. And we're going to address the questions we didn't get to during the live webinar and then the questions that we received after the live webinar. So here's the first question that we did not get to during the webinar. It sounds like actual plastics, resins, pellets are being found as in water and are assumed as microplastics. Any idea how resins are getting into rivers and oceans?
Well, there are a number of studies available about primary and secondary microplastics, and each type has its paths. About pellets, the maximum risk is during the loading and unloading operations. So when you transfer the pellets from the truck to the silo. But about this, there is a consortium of manufacturers establishing the best practices to prevent the release of any pollution. So, for example, in our factory, we process and filter all the water, including the rainwater. And actually, geosynthetics can play a major role in intercepting the microplastics in the waters by filtering them as early as possible.
Yeah, good point. And Francesco, actually looking at the question, I think it's actual plastics, resins / pellets instead of pallets, like small beads of the resin. Maybe that's what they're asking.
Yes, we have concentrated our presentation about microplastic from geosynthetics, and it means fragments released by geosynthetics. And if you go to resins, you open a much different and bigger door. So I think this is a bit out of the scope that we have established.
Yeah. Okay. Second question from the webinar. We can estimate the stress transferred on reinforcement and number of cycles during its service life. And can we determine the microplastics produced in the service life of a reinforcing geosynthetic or reinforcement in road construction?
Yes, there are specific abrasion tests that has been developed to simulate the mechanical stress during the service life of geosynthetic. And this phenomenon is more evident when you have products exposed, as it happens, for example, some coastal protection application. But it is also common to test the product for railways application, where the solicitation is quite strong and it goes by cycles because of the axis of the train and the wagons. So the answer is yes, we can approximately determine the service life of a geosynthetic also from the point of view of the stress transferred due to the number of cycles during its service life.
Right. Okay, Francesco, I want to shift now to the questions submitted after the live presentation via the survey that was sent to all the attendees. So there are about 6 questions. So the first one, can you cover the design aspects of exposed turf covers for landfills, their anticipated lifespans, replacement interval due to UV degradation, and potential for turf blade breakage, UV damage, and associated microplastics generated from the wear and tear of these new exposed turf covers?
This is a big question. My presentation was not intended to give designing guidelines for specific applications, nor to promote specific products. So I have just tried to highlight that designing with geosynthetics, whatever the application, has to take into account the fact that we are dealing with plastics, and we can see this circumstance not simply as a problem, but it can turn into an opportunity to improve the environmental performance of whatever we are designing.
Okay, great. Second question, does the fabricator industry, and I think that really means fabrication industry, run pilot tests on innovative design applications? If so, are the results published for all to read? And I'm hoping they're just talking about microplastics versus all aspects of design.
Yeah, let me say that the International Geosynthetic Society is a learned association, including academia, industry, testing institutes, and practitioners, whoever is interested in geosynthetics, and research and conferences are organized continuously. Just last week has been the European conference on geosynthetics, the 7th one, and so it is happening all over the world since about 40 years. So both at global and continental and country levels. So there is a huge library of material which is made available because the question is also about publishing, and it is available with these and other topics, reporting all the proceedings or all of these conferences with the hundreds, if not thousands, of papers and guidelines for designing and testing, and everything is available at the site of the International Geosynthetic Society. So yes, there is big effort to produce scientific and technical knowledge and to make it available to everybody.
Right, and for the listeners, the IGS digital library is available on the IGS website. You can find a lot of those papers that Scott mentioned. Okay, number 3, how much do exposed geosynthetics tend to deteriorate and diffuse throughout the environment in various forms of microplastics, thus adding marginally to the contamination problem? So that's another big question.
Well, yeah, but as I mentioned during the presentation, yes, of course, the exposed geosynthetics can theoretically deteriorate. And for this reason, it is advisable to monitor them with the time. So last week at the conference I just mentioned in Warsaw, Poland, a specific paper has been presented right about the performance of a PVC liner membrane during more than 30 years. It has been monitored for more than 30 years. And please note that we are talking about a product designed more or less 40 years ago, so not as efficient as the modern ones. But the result after such a long time is the PVC was still totally there. That has been a loss of plasticizers, of course, but this release didn't affect the efficiency for waterproofing of the the membrane. And so the system was still working well, and it has been decided to substitute it before having any chance to have any release of plastics from it after 37 years of service, of exposed service, and to prevent any problems. So that, of course, it has been necessary to treat the wastes, hopefully by recycling them, but with no release of microplastics. So for cases without measurements, of course, we can make only guesses. But and also about the marginal addition, it is always necessary to weigh the cost and the benefits. So because as far as the benefits are bigger than the cost in environmental terms, but not only in terms of microplastic, but for example also in reducing the greenhouse gases emission, then it is worth to install geosynthetics.
Right. Okay, great. Next question is, what is your opinion on fiberglass geogrid reinforcement for asphalt pavement? With the relatively short pavement design life, roughly 20 years, would you consider fiberglass to be detrimental to the microplastics around the world? Do you know of ways to improve the recyclability of fiberglass reinforcement, geogrid reinforcement?
Well, clearly, the glass cannot be included in the family of microplastics because it is something different as a material. And I don't want to say extend my answers to topics that I didn't study in detail. But what I can recommend anyway is to use the same method of measuring and assessing the real cases. As in my opinion, it's always risky to use an say ideologic approach so that something is good or bad for any situation. So I guess there are situations where fiberglass can be good and giving advantages, and in some cases other products can perform better. Also in relation with the maintenance budget of the road agencies, because they are very, very different around the world. Say in an African country cannot be the same of Canada and so on.
Right. Okay, fifth question after the webinar. What is the best way to reduce the contribution of microplastics from non-woven geotextiles installed in flowing water channels so the geotextiles in contact with both water and air?
As it happens in other situations, such as the slopes of a landfill, for example, it is possible to calculate the curve of the performances of the products by calculating the exposure to light irradiation. So a slope facing to the south will have a situation which is different from the one looking to the north. So first, it is necessary to consider latitude, inclination of the slope, and the orientation of the exposure. This kind is possible to calculate the irradiation in kilo-Langleys. And once you have this kind of information, and you know the level of performance you want to have after a certain number of years of service, you can determine the level of the initial performance so that you can have a look to what should be the grade of UV stabilization, the type of the correct type of polymer you need. So to perform the function you are assigning to the geotextile within your project. So of course the supplier has to know and provide the degradation curve of the product. And the same happens for the mechanical abrasion. So again, an accurate designing will allow you to maximize the good performance and reduce even the microplastics emissions.
Okay. Last question from the survey. The fibers eventually get worn away by the flowing water and UV degradation. Are either polypropylene or polyester fibers less harmful, or do both have the same effect? And it sounds like the same author submitted this question too.
Well, it is necessary to refer to a bit of chemistry, because there is a polyester is obtained by condensation. The polymer is obtained by condensation. It means that the ingredients that you put together, And during the process of polymerization, they release a molecule of water. So it happens that in certain chemical situations, you need a bit of humidity, so you make some water available, high pH, so high basic environment, and a bit of temperature, as it happens, for example, typically with the fresh concrete. Then the chemical locks of the molecules of polyester break, and you have hydrolysis. So some of the products of the hydrolysis of polyester can be dangerous. But here we talk not about microplastics, so not about fragments of the bigger piece of plastics, but about possible dangerous releases of other substances. And I have tried to stress that we should focus on dangerous substances rather than on plastics at large. So with polypropylene, the polymerization process is different because you get it by addition. So you have some catalyzers, and the monomers add each to the other, so you get your molecule. So the polypropylene, it's much more chemically stable at the end than polyester in different kind of environments. So the weak point of polypropylene is the photooxidation, as everybody knows. But so in that case, you just have to know that you have to use some additives to improve the reaction to photooxidation. So it can be just a simple carbon black pigment, or something more sophisticated as the hindered amine light stabilizers or something like that. But yeah, so the general answer is that polypropylene is more suitable in certain kind of chemical circumstances, and much more inert from the chemical point of view, and not releasing the same kind of substances polyester can release.
Great. So people can choose between polypropylene and polyester textiles. Great. Okay,
sure.
Francesco, that is all the questions we have from the post-webinar. So thank you so much for joining us again from Italy, near Venice. And that is all the questions we have. If you have additional questions or would like additional information, please send your questions to the FGI at fabricatedgeomembrane@gmail.com, or download the webinar slides, and Francesco's email address is on the slide right after his presentation, and you can email Francesco directly. So thank you so much, Francesco.
I will be happy to answer any question.
Great, that's fantastic, because you'll probably get some email. So thanks for joining us, Francesco.
Many thanks to you, and see you soon.
Okay.